Explanation for gravity is that matter bends space. And so you put mass in a place in space, it warps space-time, and objects are not feeling a force of gravity, they're just following the natural curvature. And so this is a sheet of Lycra. Where do you get this? This is my old bike shorts. And so you put matter and it warps space-time. And so if I have another object, it also warps space-time. They feel that and they're attracted to each other. And so that's Einstein's picture of gravity. Objects warp space-time, feel that curvature, and move accordingly. If you have more mass, it's going to bend space-time more. And so if you have objects here, they are going to respond to that, right? And so you put something there, now it's attracted. Well, instead of just letting go of one, what if I give it a sideways push? Now it orbits. Now it's losing energy, which wouldn't happen in the solar system, right? Not noticeably. There's some perturbations from other planets and things, but this one does lose energy and spirals in. When you study the solar system, all the planets are going around the sun the same way. Why is that? Did God decide that he only liked clockwise, or depends on whether he's above or below the solar system, right? Why is everything going in the same direction? Well, the answer is it wasn't. Different directions. But there was a preferred direction. The disk it formed from had a slight preference one way versus another, and things going the opposite way got eliminated, and when it's all said and done, everything's going the same way.
Can you do that again?
And so, it won't work then. And so I have slightly more in one hand than another, but I don't consciously do that. And you want to get them so they spread out a little when you throw it.
It's because they're colliding with each other that you...
The ones going the wrong way get eliminated, right? Now there also would have been, this is where this analogy breaks down. There's, another dimension, right? But those things that were out of the plane also, that weren't near the preferred plane, also got eliminated. And so but they bend space-time too, right? And so maybe, you can get one thing to orbit another. I think I can do a little better. There we go.
Oh my God.
So the Earth-Moon system, maybe? And so you can see that this seam masses in. And so when we went to the moon, when we first started, we sent our spaceships on what are called free return trajectories. So, and they would come back in like a figure eight. And so that lets you show, now of course the moon's a lot smaller, but if you look at the plots of the free return trajectory back from the Apollo program, you'll see it has a figure eight sort of shape. And so this takes a little bit of practice to be able to do the figure eight. These clamps around here, you can adjust it to make it tighter if it's not working. The dark energy, we have our dark energy pole.
It's over there.
I happen to have an extra pole. I guess any of these would work. And so I'm just thinking, oh, dark energy, what is that? That makes everything come apart, right? And so dark energy would be that. And so stuff goes apart rather than toward it. And so I go through that spiel. Maybe it takes me 10, 15 minutes talking with the kids, just stuff they're not familiar with. And then I just let them play. And so that's where we discovered the Earth-Moon thing. Is I just let them play, and they're like, Mr. Burns, come over here and look. And they were all excited because they discovered that. I said, oh yeah, it's got it.
Yeah, very cool.
Wow, so wow.